Today our objectives, oops, go to Black, shh, is we're going to continue to look at how does a dilation affect the coordinates. We're kind of go a little bit in the opposite direction. So study the effects of dilations on coordinates of a figure. I'm going to change that to dilation. And the other thing we're going to just do is to distinguish, come on you, oh. An enlargement from a reduction. Okay. So we're going to do things a little differently. We're going to give you a preimage. We're going to give you coordinates for the preimage. We're going to give you coordinates, let's see. We'll actually give you the coordinates of the image, so we'll draw that, and then you'll see if you can come up with the scale factor. Okay, so let's go ahead, or no, we'll start with we'll do the preimage. Let's do that. Okay. This is reduction. So let's put in my graph here. And let's see what we need to get up to. We need to go to 6s. Shh. That might not be enough. That might not be enough. We're going to have to move him too. One more. That'll work. Shh. You guys should be copying this down.
How many marks?
6. All directions. Yes, you've reached the stage where you can count in your head. Yes. Okay, so what I'm going to do is I'm going to draw a pre-image. And I'm going to put him in blue. So let's see. And what I'm going to do is write a chart of his points as we go through it. So we have the preimage. And we have an image. So we have x, y would be for our preimage. And we're going to try to figure out what our scale is for our image. So as I do each point, I'm going to write the coordinates in. So we have one point that's at -1, 1. We have another point that is at 0, 2. We have another point that's at 2, 2. Oh no, wait a second. I did something wrong. Hold on. Go back. Should be at -1, 2. And then it should be at 2, 2. And then we're going to go down to 2, -1. And we're going to go to 1, negative 1. And we're going to go to 1, negative 2. We're going to go to negative 2, negative 2. And then we're going to go up to negative 2, positive 1.
That's a lot.
Yep. So if we connect, that's what our shape looks like. Okay. So now what I'm going to do is tell you that the image's coordinates, Aaron, you writing this down, buddy? You got to do this whole graph here. Is we're going to change these. And instead of it being x, y, we're going to do 3x, 3y. So what do you think that's going to do to the coordinates negative 1, 1? What are we going to actually do to those coordinates so that my image is going to be a 3x, 3y? One person has an idea? 2 people have an idea? 3? Joey, what do you think it's telling you to do?
It's going to tell you to multiply the image numbers by 3.
Okay. So we would do this, which would give us negative 3, 3. Okay, negative 3, 3. And that's precisely what it tells us to do. So that's what we're going to do, is multiply all of our coordinates by 3, and then draw in our image. So this one's going to be negative 1 times 3, 2 times 3. So I'm at negative 3, 6. This one's at 2, 2, so 2 times 3 is 6, 2 times 3 is 6, so then I'm at 6, 6. And then 2 times 3 is 6, negative 1 times 3 is negative 3, so we go to 6, negative 3, oops, not 4.
On a test, are we going to have to show how we did it? Like, how are we going to multiply it all?
Could be all sorts of different things that I may have you do. Okay, we'll just have to wait and find out, won't we? So then we get 3 times 1 and 3 times negative 1, so we get 3, negative 3. We have 3 times 1 is 3, 3 times negative 2 is negative 6, so we have 3, negative 6. Shh. We have 3 times negative 2 is negative 6, 2 times 3 is 6, so we're at negative 6, positive 6. And then negative 2 times 3 is negative 6, 1 times 3 is 3, so then we go to negative 6, positive 3. And then we just connect up. I think I missed one over here. What's this one? Negative 2, 2. That's negative 6. Oh, that should be negative 6. Oh, this one should be negative 2, negative 2. Looks like I forgot the second negative on him. Sorry, this one here. So that should make it 2 negatives. I was thinking that point looked funny. So it should be negative 6, negative 6. So this one is not here. That one is here. There we go. Okay. So remember, our pre-image is blue and our image is red. So what kind of dilation did I just do? We have 2 choices. Second objective. Yeah, it's definitely an enlargement, okay? If I asked you what would be the scale factor, what would you say the scale factor is? Say it real loud, Kyler.
3.
Yeah, because what we're doing is we're taking every coordinate and we're tripling it. So that tells us that's our scale factors of 3. And remember we talked about at the end of our notes what do we need a scale factor to be to show us we're getting an enlargement? What numbers would you see for our scale factor if we're getting an enlargement? Do you remember? Yeah, anything greater than 1, okay? All right, cool. That was easy. That looks pretty neat. All right, let's do one more shape. You guys ready? Okay, I'll pause it. One thing that I didn't get to with you guys was, remember I told you we were going to talk about that center of dilation? So the center of dilation says draw a line through corresponding vertices.
That's like a Christmas
Yep.
show there.
Oops, that didn't quite make it. So basically, oh, I know, because I got this guy wrong. Let's try that again. So you can see right here, that point is your point of your center of dilation. It happens to be the origin. Now, really what's happening is that point is out here. So this is almost like a three-dimensional shape that you're making. Okay, so that's pretty cool. All right, let's do one more. Everybody ready?
No.
So let's just add one more thing in here, because Isabel had a good question. She says, how do we again figure out the scale factor? So for us, because we have horizontal and vertical lines, it's really easy to count the lengths of shapes. So this side here has a length of 9, and its corresponding side here has a length of 3. And we had talked about comparing the image, let's see, where can I put this here, to the original or pre-image, and we would have 9 divided by 3, which gives us 3. That takes us back to how we can calculate a scale factor, even though they kind of did tell us in the chart that that was going to be our scale factor. Okay? All right. So let's do one more. And this time I'm going to kind of turn the tables a little bit. And I'm going to give us a different set of directions. And our directions are going to ask us to graph the image of triangle XYZ after dilation of scale factor 1/3 and the origin is the center. And then we're going to write an algebraic rule for the dilation. So again, our image is just going to be dealing with quadrant 1. We need to go up to 9. On both axes. We need to label the x and y axis, and we need to put in at least every other number on the tick mark. You can't make somebody assume you're counting by ones. So our first vertex is going to be at 3, 3. So this is going to be our image, our pre-image, excuse me. That's x. Y is going to be at 9, 9. So I'm going to put over here, x is at 3, 3. Y is at 9, 9. And we're going to put z at 3, 9. So this is our pre-image. All right, now we want to do our image after applying the scale factor of 1/3. So what are we going to do to come up with the coordinates for our image? Okay, you guys can't look around the room and stare out the window and think you're going to get an answer out there. You guys actually need to focus. So what am I going to do to figure out where x prime gets placed? Kayla. How am I going to figure out the coordinates of x prime if the scale factor is 1/3?
Oh, me.
You're Kayla.
Oh, I thought you said Caitlin.
No, I said Kayla. Okay, Kayla, are we going to answer?
If you're trying to look at the scale factor of 1/3, wouldn't you multiply 3 times 1/3? But wouldn't you have to make it a decimal first?
No, no. Don't work with decimals. No, that's bad news. So all we do is take our original coordinates and multiply them by the scale factor. So what's 3 times 1/3? 1. So we get 1, 1. So that's where x prime gets placed. Okay, where's y prime going to go? Ryan S. What am I going to do? No, I don't know is not an acceptable answer because it's right in front of you. Excuse me? Okay, well, that's your choice, and that means you're going to lose out on understanding, but it's written there on front of the board for you. What did I do to the original coordinates for x of 3, 3 to get to x prime's coordinates of 1, 1? What does it show doing right here to get to 1, 1? And what did I multiply by? Pardon me? You don't know how to read a fraction? What's the fraction's name? 1/3. So the coordinates for y were 9, so we're going to multiply each of them by 1/3. So we're going to find 3, 3, and that's y prime. We're going to do that one more time with z's coordinates to figure out z prime's coordinates. And we get 1, 3. Okay? What kind of dilation did we just do? From blue to red. It's a reduction. Smaller is not the choice. We have enlargement or we have a reduction. So this is a reduction. Now they did ask us to do one more thing, and they asked us to write the rule. And this is as simple as it is. Ryan S., knock it off. The rule is these are the coordinates that we began with. But to get to the new coordinates, we took our original coordinates and multiplied them by 1/3. So we have 1/3 x, comma 1/3 y. Kia, we're taking notes. You need to take the notes. I just wrote and your hands were in your lap. Jacob.
So how do you know whether to make it smaller or larger?
You follow the directions that are given to you based on what the scale factor says. I'm not determining I'm going to make a reduction, I'm going to make an enlargement. I'm looking at what does my scale factor tell me to do, and then I can eyeball looking at to my original compared to the image. That's how it does. Alrighty. That's it.